Hello everyone and welcome back to our channel. In this video, we will encounter a problem from sequences and we'll see how the ingenious tool of matrices helps unveil the pattern here. So let us start with the question. The question reads as that AN and BN be two sequences defined by first relation and the second relation. The two relations has been provided to us. AN plus 1 is given in terms of AN and BN, and Bn plus 1 is provided in terms of An and Bn once again. Further, A1 and B1 both are 1, then we need to find the number of positive divisors of log A46 B31 to the base 2. Well, basically in this question, what we need to do is get the values of A46 and B31. If we can get these values, then we are going to put it over here and then we will see what we are getting. Later on, we can think of getting the number of divisors of that number, right? Chaliye, so let's start with the question. First of all, I'm just going to concentrate on the two equations 1 and 2, which are given in the question. Let us rewrite it by clubbing all the terms of An together. So I have clubbed the terms of An and then also clubbing the terms of Bn together. So when you club the terms of Bn together, what we are getting is negative sign taken common, root 3 minus 1 Bn. Similarly, Bn plus 1 can be written as clubbing all the terms of An together and clubbing all the terms of Bn together. Fine. An plus 1, Bn plus 1 are written in terms of A and Bn, but now I'm going to rewrite both of them as A and Bn. That means now you can also write A and Bn in terms of An minus 1, Bn minus 1. Or you can say that you can write it as root 3 plus 1, An minus 1, minus root 3 minus 1, Bn minus 1. Similarly, this will become root 3 minus 1, An minus 1, minus root 3 plus 1, Bn minus 1. Now, when you look at these two equations, you will realize that An and Bn both are being represented in the form of An minus 1 and Bn minus 1. यानी दो ही वेरिएबल के फॉर्म में An and Bn को represent किया गया है. So I'm going to represent these two equations, the two equations in the matrix form. Let us represent the two equations in the matrix form. I'm going to write An, Bn over here. On the right hand side, the first matrix will be the coefficient matrix, root 3 plus 1, minus of root 3 minus 1. Then we have root 3 minus 1. And then we have minus of root 3 plus 1, right? Minus of root 3 plus 1. This is what we are going to have. So let me just check whether we have this negative sign, because I think Bn plus 1. When you club the terms of Bn, it is root 3 plus 1. So let me make the correction here. It is plus only. So this is the coefficient matrix. Along with that, you will have to write down the matrix An minus 1, Bn minus 1, correct? So we have represented the relation given by them in the matrix form. When you look at this matrix, the coefficient matrix, look at the coefficients that you have written over here. If I divide each of these entries by 2 root 2, if I divide each of these entries by 2 root 2, then I will be able to represent these values in the form of some trigonometric ratio. Like, let us multiply and divide it by 2 root 2. ठीक है, 2 root 2 से multiply करते हैं, divide करते हैं. जो multiply किया वो यहाँ लिखा, and after dividing, the very first row, first column term will become root 3 plus 1 by 2 root 2. But root 3 plus 1 by 2 root 2 means you can write it as cos pi by 12, right? Root 3 plus 1 by 2 root 2 is the value of cos pi by 12. So I actually represented the value in the form of cos. Similarly, minus of root 3 minus 1 by 2 root 2 will give me minus sin pi by 12, correct? Similarly, this will become sin pi by 12 and this value will become cos pi by 12. And the second matrix on the right hand side is this one. Well, this is a very beautiful matrix. Why this is a beautiful matrix? Because we have a relation for this kind of matrix. What is that special relation? Let me tell you. काफी अच्छा एक relation होता है जो आपको दिमाग में अपने mind में रखना है whenever you are dealing with it. Whenever you come across a matrix of the type cos theta minus sin theta, cos theta, whole raised to the power n. Whenever you come across this type of expression, what you are going to get is directly this n will shift in front of the angle. And you will get cosine theta minus sin n theta, cos n theta, correct? This is what we are going to get. So this relation, the special type of matrix has been created over here. And now this will help us in identifying or writing an minus 1 या an in terms of a1, b1. How we are going to make use of that? Now let us see. So obviously this is important relation. So I'm marking it as a hashtag relation. Okay. And I'll go back to the star relation. Star relation mein I will be using this relation repeatedly. Repeatedly means what you are going to write now. In the next step, now I'm going to write that I got the matrix A and Bn is equals to right hand side 2 root 2 and the matrix was already there. But now I'm going to write it once more. That means after that, an minus 1, bn minus 1 matrix, that will become 2 root 2. Again, the same matrix. What is the matrix? We have the matrix as cos pi by 12 minus sin pi by 12, sin pi by 12, cos pi by 12. Whole square. Now it will become an minus 2, bn minus 2, right? So at least we have expressed a and bn in terms of an minus 2 and bn minus 2. Repeat the process till you reach a1, b1. So now you can see that when we had earlier n minus 1 here, the index was 1. Now I have an minus 2 here, so the index has become 2. If you keep on repeating it like this till you reach a1, b1 over here, the index will also change accordingly, right? What we are going to write on the right hand side now is 2 root 2 power something, and the matrix is cos pi by 12 minus sin pi by 12, sin pi by 12, cos pi by 12, whole raised to the power something, a1. Now how you can write a1? A1 ko you can write as an minus n minus 1, right? And this is b1. So this n minus 1 indicates that the index should be n minus 1 over here. This n minus 1 can now be shifted in front of the angle because this is that special kind of matrix which I told you. Okay, if you raise the index over there, you will be getting a relation of this kind. So I will definitely use it once I get to know what exact values I need to find out. अभी तो हमने एक जनरल रिलेशन निकाल दिया, तो मैं इस रिलेशन में इसे a1 रिप्रेजेंट कर देती हूँ अब एक बार. तो ये रहा a1 b1. a1 b1 means what? This is 1 1. So the matrix जो हमारे पास लिखी हुई आ रही है, this is a column matrix 1 1. What I need to find out in the question, I need two values in this question. What two values we need in the question? The first value that we need in the question is a46 and the second one is b31. So a46, b31. Let us concentrate on these two values now. A46 and B31. First of all, I'm going to put n is equals to 46 both the sides. To get the value of A46, obviously. A46, B46. I don't need B46, but वो तो अपने आप calculation में आएगा ही. So let us concentrate on now the calculation part. Right hand side 2 root 2, whole power 45. The index I will be writing in front of the angle. So n minus 1 is 45. 45 pi by 12. What is 45 pi by 12? 45 pi by 12 I need to check. So I just divided it with 3. It will become 15. It will become 4. 15 pi by 4. What is 15 pi by 4? 15 pi by 4 means you are actually writing it as 4 pi minus pi by 4. So it is actually in the fourth quadrant, right? This angle is in fourth quadrant. I need to write cos 15 pi by 4. What is cos 15 pi by 4? Answer will be positive 1 by root 2. Minus sine 15 pi by 4. 15 pi by 4, because it belongs to fourth quadrant, sine is going to have a negative value. But because of this negative, two negatives will give me positive answer 1 by root 2. This will become 1 by root 2 with the negative sign. This is 1 by root 2. And then finally we have the matrix here 1 1, the column matrix. Correct? Next step. I feel that 1 by root 2 can be taken common from here. So I'm going to take that common. Meanwhile, I'll also simplify this one, which is going to be 2 power 45. Root 2 power 44 is 2 power 22. And then one more root 2. We have taken 1 by root 2 common. And we are left out with 1, 1, minus 1, 1. Multiplied by 1, 1. We can simplify this matrix. The product of these two matrices can easily be taken. इसे cancel किया. What we are getting is 2 power 68, right? 2 power 67 right now, correct? Taking the product of these two matrices gives me first row, first column, second row, first column, which ultimately gives me the matrix as 2 power 68, and this is 0. This is the matrix A, n. N means here we have taken it as 46, B 46. Well, I'm interested only in calculating A 46. So I calculated it and I got A 46 as 2 power 68. Had they asked B 46 in the question, I would have written my answer as 0. But वो तो पूछा नहीं है. तो इसलिए अब मुझे वापस same calculation करना होगा and we will have to find out the value of B 31. So let us go back to this relation. I need B 31. So I'm going to put n is equals to 31 both the sides. Let us keep n is equals to 31 both the sides now. So holding it over here and calculation for B 31 has now started. So I started with B 31, A 31 or A 31, B 31 like this. Right inside 2 root 2 power 30. Then we have cos. Pi by 12 was already there, but you have to shift 30 in front of it. So 30 pi by 12. What do you mean by 30 pi by 12? Let's simplify it. 30 pi by 12. I can divide both numerator and denominator by 6. So I'm dividing it. It is 5 pi by 2. 5 pi by 2 means we have 5 pi by 2. Cos 5 pi by 2, 0. 5 pi by 2 means actually 2 pi plus pi by 2. So sin pi by 2 or sin 5 pi by 2 will have the same answer. That means you will have to write here minus 1. Then you will be writing 1 here. And after that, the last row, last column will have the value once again 0. And this is 1, 1. Correct? I'm going to multiply these two matrices together and will also simplify this one. This will give me 2 raised to the power 30 and root 2 power 30 means 2 power 15. Taking the product of two matrices gives me first row, first column, second row, first column. Ultimately, the value when we shift this number inside the matrix, what we are getting is 2 power 45 with a negative sign here. And here it is 2 raised to the power 45. Comparing both sides, I get the value of B31. We are getting the value of B31 as 2 power 45. So now we have the value of B31. We also have the value of A46, right? We needed these two values. A46 चाहिए था, हमें B31 चाहिए था. अब दोनों values आप ध्यान से देख लो because now I'm going to put it in the question. B31 2 power 45 है, A46 is 2 power 68. Let us go back to the question. Because now I have all the values, I'm going back to the question and putting it over here. So the question says that what you need to do is, you need to calculate this value. After that, whatever number you are getting, you have to get the number of positive divisors of that number, right? So first of all, I'm going to put the values here. It was 2 power 68 and 2 power 45 or 46. I think 45, but let us verify it once again. हमारे पास एक value आ रहा है 2 power 68 and the other value that we are getting is 2 power 45, correct. So 2 power 68, 2 power 45 का product, we have to write in front of log to the base 2. What we are getting is log to the base 2, 2 raised to the power 3, 1, 1. That means 113. So the value of this expression is 113. I'm getting this number as 113, whose number of positive divisors are to be calculated. But what do you say about 113? Isn't it a prime number? 113 is a prime number. That means you can write it only as 1 into 113. So what should be the answer to the question? Now we can say that because we need to find out how many number of positive divisors of this particular number are there, we can say the answer is going to be 2. So for this question, we will say that the answer is equals to 2. So I hope you have enjoyed this question. So please don't forget to like and share the video and subscribe the channel for more such content. Thank you for watching. See you in the next video. Meanwhile, take care and bye-bye.